Hello, this is section 2.5 for Calc survey, and today we're going to be talking about marginal cost and revenue, and that might sound familiar. We talked about this in chapter 1 when we were dealing with linear functions, and marginal cost was the slope of your linear function for your cost function, and marginal revenue was the slope of your linear revenue function. So for our purposes, we're going to kind of expand away from those linear functions. And if marginal cost is the slope, then we can use that slope formula. So y2 minus y1 over x2 minus x1. And I know it looks weird, but if you think about it, if you're producing units, so if you're out in the business world and you're not going to be looking at 0.001 away, you're going to want to produce the next unit. So your slope or your derivative for your marginal cost, notice we're 1 unit away. How much does it cost to produce the next unit? Or how much are you going to make when you sell the next product? So we're looking at the next, we're looking in terms of units, not that 0.001 decimal point, because that's not realistic in the real world. Okay, so the cost to produce the next unit is what you need to think of when you see marginal cost. And we'll do some examples. All right, so given the following graph of a cost and revenue function, determine the production level for which the company will make a profit. So here's where these functions need to start popping in your head. Remember, revenue was price times quantity. Profit is revenue minus cost, and that just needs to, that needs to be immediate. So looking at the cost and revenue graphs, you can see in this area right here, that is when your revenue is greater than your cost. That's when you're actually earning a profit. At these 2 points is when your profit is 0. You're not losing money, but you're not earning any money. Okay, so it's when the profit, generate a profit. Okay, so when the following graphs of marginal revenue and marginal cost. So this means we're looking at the derivative graphs now. These are now derivative graphs. Should the company make the 56th item justify your answer? All right, so on this graph, marginal cost, so you'll notice it's positive. So that means your cost function is increasing, and it's a pretty steep line here. Your marginal revenue is also always positive, so your revenue function is increasing as well. But the key thing is at 56, your marginal cost is greater than your marginal revenue. So think about this. If you're running a business, do you want your cost growing faster than your revenue? I would think that's a bad thing. So no, it's not a good thing. So because marginal cost is greater than marginal revenue, cost is going up faster than revenue, you would definitely make the recommendation of no. Right? You wouldn't want to produce the next item. Now, on this graph, now I want to point out marginal cost is still positive. So meaning our cost function is still increasing. But remember, if your derivative was decreasing, your cost function must be concave down. Okay. Now in this case, your marginal revenue is also positive, meaning your revenue function is increasing. But do we want to recommend them produce the next item? So at 56, your marginal revenue is greater than your marginal cost. So your revenue is growing faster than your cost. That's a good thing. So yes, you would recommend producing the next item. All right, so given the following graph of a revenue function. So here's our revenue function here. So keep track of what you're looking at. Up here, these were derivative graphs. This is telling us how fast cost and revenue are going up. Right? Whereas here, we're back to just, this is saying you sell this many items, this is how much revenue you make. So at what production level does marginal revenue appear to be the smallest? Marginal revenue. So remember, that's the derivative. That's the slope of the tangent line. So where is the slope of the tangent line look to be the smallest? So if you look at the tangent line here, it's pretty flat. And then it's only getting steeper. So x sub 1, that's going to be your smallest marginal revenue. Then at what production does the marginal revenue appear to be the largest? Well, that's going to be your steepest slope. So x sub 3. So you got to start thinking marginal revenue, marginal cost. You have to immediately start to think derivatives, slope of the tangent line. Okay, so in the figure, estimate the marginal revenue when the level of production is 2 units and interpret it. So I put on here, answers will vary because we're sketching a tangent line at 2. So here's my tangent line at 2, and depending on what yours looks like, I sketched my tangent line. I try to find another point somewhere along that line. Looks like I probably used the intercept. Yeah, so the point on the curve, and then mine looked like it went through 0, 2.5. Found the slope, but of course, we're all going to get varying answers. So as long as you have a justifiable answer. Okay, and then notice my units. I'm saying increasing 35 cents per unit. And then at 4, so again, I drew my tangent line, found another point on my line, found the slope, 0.9, so I'm saying it's increasing 90 cents per unit. So just do the best you can. Okay, and then I'm going to move my face up here. So to produce 600 items, the total cost is $6,500 and the marginal cost is $18. Estimate the cost of producing 601, 599, and 700. Okay, this is back to that linear approximation problem, okay, or the tangent line approximation, however you want to call it. So I wrote down the formula for you just to refresh your memory. So it's what you know, start with what you know on the curve, and then you're adding the change in x times the derivative. So we're given 6,500. So at 601, that's the change in x is 1, and the derivative is 0.18. So just add that together, and there you go. That would be an estimation. If you're going to your boss, you could say, I have an estimation of 6,518 for 601. And then at 599, now be careful, you're going backwards. So still start with what you know, but your change in x is -1 times 0.18. That's what you get. And then finally 700. Now we talked about you want your change in x to be small to get a good estimation. So this isn't going to give us a very good estimation, but I guess if you're desperate, it at least gives you something. So 6,500 plus, but your change in x is 100 away from 600 times 0.18, or times 18. Sorry, I thought that was 0.18. Sorry, times 0.18, and you get 8,300. And there you go. So just please do your homework. That marginal cost, marginal revenue, it's the cost to produce the next item, or how much money you would make producing the next item. So you have to think of it in terms as 1 unit away instead of the really close estimate of 0.001 that we had been doing. So, but do your homework. We'll answer questions in class.